All right, people, here we go. We are into logarithms. Logarithms sometimes scare people a little bit. The thing is, once you get used to them, they're not bad. They're pretty easy, but it takes practice. You have to be willing to mess up and make mistakes and get through it to get used to it, right? Like walking is hard when you're like, I don't know, 9 months old or something, right? But you keep doing it, keep falling down. Eventually, you're pretty good. Most of you are pretty good most of the time, right? And walking now. Same thing with logarithms, right? You have to put in the work. You have to put in the practice. You have to get used to converting from exponential to logarithmic. And then once you do that enough times, it kind of becomes clear. So don't be afraid to put in the work. So here we go. If this is the base 3, so if we're base 3 and we have the result 9, what would the exponent have to be? So something with a base 3 that equals 9, the exponent would have to be 2. Okay? 3 with the result of 27. So the base is 3, the end result is 27. What did the exponent have to be? Has to be a 3, right? 10 has the result 1,000. So if the base is 10 and we end up with 1,000, the exponent had to be 3, right? Because 10 to the third power is 1,000. 3 cubed is 27. 3 squared is 9. We know this, right? What we just did is a bunch of logarithms, okay? So we're going to write the word log, okay, sometimes in cursive. Underneath it, so if this is the line, like on a line of paper, underneath as a subscript, we're going to write the base. So log of base 3. And then up here, sometimes in parentheses, it doesn't have to be in parentheses. We're going to put the result, and then this equals the exponent. So log base 3 of 9 equals 2. So if we have a base of 3 and the end result is a 9, the exponent had to be 2. I look at it like this. 3 squared equals 9. Okay? Let's do the same thing here. I'm going to use this line that already exists as the line. You have to do this right. Otherwise, you're going to get yourself in trouble. So log subscript 3 back on the line 27 equals, so log base 3 of 27 equals 3, because 3 to the third power is 27. Okay? Log base 10. Again, 10 is the subscript. That's the base. The argument or the result goes here, 1,000 back on the line, and that equals 3, because 10 to the third power is 1,000. Okay, so getting used to writing in logarithm form, making sure that everything's on the normal line except for the base. The base is a subscript. Okay, cool, cool. All right, so logarithmic form looks like this. Log subscript base of the result equals the exponent. It's good to be able to convert between exponential and logarithmic. So if I said 3 squared equals 9, to go into logarithmic, I'm going to go log. What's the base? 3. What's the result? 9 equals the exponent. Okay, these are equivalent to each other, right? 3 squared equals 9 is basically saying the same thing as log base 3 of 9 equals 2, just in reverse. Okay, Mitch Calvert's rule, if you look outside my classroom, it's like the Calvert quad. Okay, he came to me, he's like, yo, Mr. Rebuff, I got this thing. And he said this, the base stays the base, and the others change place. It rhymes. Mitch Calvert. And I've used this ever since. And you're going to hear it and you're going to put that into your brain. The base stays the base and the rest change place, or the others change place. Up to you. Okay. So when we convert either in log to logarithmic form from exponential or to exponential form from logarithmic, we think the base stays the base and the others change place. And we got this. So if I'm converting into logarithmic form, I'm going to start by saying log, right? Again, it doesn't have to be cursive. I like to use cursive on this, but I didn't there. I printed. So log, the base stays the base. And then I'm going to put an equal sign here, and the other two are going to change place. So 81 is going to go on this side. and the 4 is going to go over here. So log base 3 of 81 equals 4. Cool. The base stayed the base, and the others changed place. So give this a try on your own. I'll give you a hint. It starts with log. The base stays the base, and the others change place. All right. Did you put 2 down in the subscript as the base, and then the 8, and then equals 3? And again, a quick check. 2 to the third power equals 8. Just like 3 to the fourth power equals 81. Cool, cool. All right. Let's do exponential form. Again, base stays the base and the others change place. So the base of the log is 3. I'm going to put an equal sign. The log goes away because we're going away from logarithmic form. So we're converting into exponential form, right? So the base stays the base. The other two are going to change place. So we'll get 3 squared equals 9. Cool. All right. Give this one a shot. It's a little more challenging. Okay. But I'll give you a hint. The base stays the base and the others change place. Did you get 3 to the negative 1 equals 1/3? If you did, pat yourself on the back, right? 3 to the negative first power is just 1/3. Cool. All right. There's a couple special logarithms out there. Okay. If we have log base 10 of x, okay, base 10, okay, and these are going to be on your calculator. So if you look on the left side of your calculator and it just says log, right, without a base, okay, or anytime you see just plain old log without a base, right, that is because we're a base 10. So log of x equals log base 10 of x. So if you don't see a base, it is base 10, and we call this common log. The common log of x is what I would say. So I wouldn't say log of x, I would say the common log of x because it doesn't have a 10. In science, we use base 10 a whole lot, right? With scientific notation, base 10 is a big thing, right? Um, so, um, Anyways, we use that a lot. All right. We also use the natural number e. So natural number e. We talked about that when we did like exponential growth and A equals P times E to the RT, right? That natural number E is really important. So important that it gets its own base. And it is right here. Where we found that E before to do A equals PERT, that's where we find ln. Okay? So ln is log base E. So log base E of x is ln of x. Okay, again, we don't see a base here. When the base goes away, you're either in base 10 or in base E. If it just says log, you're base 10. If it says ln, that's log natural in French, log natural. And we read it as the natural log of x. Natural log of x. But in reality, we just say ln of x. Okay. So in our parlance, we say ln of x is how we would say that. Okay. But it basically means log base e. A lot of times when you see log base ln of x, I invite you to write log base e of x. It's going to be helpful when you convert. Same thing here. When you see common log of x, go ahead and add that 10 in there. Totally fine to do. Okay. And it can help us, especially when we go into conversions. Sound cool? Cool. All right, so here we go. We got some rules of logarithms. Okay, we got some basics that I want to throw down so you have them. Log base b of 1 equals 0. Okay, and this is because if we convert it, we'd have base stays the base and the others change place. B to the 0 equals 1. Okay, anything to the 0 power is 1, so log base b of 1 is 0. Okay, so that's the reason why. And b cannot be 0, just so you know. Base cannot be 0. Okay. All right, product rules. Oh, we have one more. Sorry. So that's one of them. The other rule is log base b of b equals 1. And the reason why is because b, base stays the base, and the others change place. B to the first equals b. Anything to the first power is itself. Okay, so going back to our kind of exponential rules here, what b to the 0 power means, right, leads us to this. What b to the first power means leads us to this. B to the first equals b. B to the 0 equals 1. Cool. All right, product and quotient rules are going to look like this. Log base b of, if I multiply things together, product means multiply, m times n is equal to log base b of m plus log base b of n. Okay, so I can separate. If it's multiplication on the inside, I can separate it out like this. Okay, um, cool. I could give an example here. Let's go. Log base 3 of 4x, right? Usually we'll put that in a parenthesis. Would be log base 3 of 4 plus log base 3 of x. Okay, turns into addition, right? So multiplication turns into addition. Quotient rule for this, log base b of m divided by n is equal to, well, if when we multiplied it turned into addition, anybody want to take a wild guess what's going to happen in between these two? Yeah, it's going to be subtraction. Okay. So this one, log base 3 of, I don't know, x over 5 is equal to log base 3 of x minus log base 3 of 5. Okay, so there's just an example of how to use it for you. All right. Power rule is my favorite one. This is, I call it the jump on or jump off the log rule. Okay, so log base b of m raised to the k power. So you see this is an exponent equals k times log base b of m. Okay, see how an exponent jumps off the log. It's really kind of fun. So if we have, let's go log natural. So natural log of x squared is equal to 2 times ln of x. Okay, so that 2 gets to jump off the log. So exponents can jump off. So fun, so fun. All right, cool. How do you remember these? Well, one way to remember them is remember logarithms and exponentials are similar, right? So think about this for product rule. What happens when we multiply two powers, right, with the same base? We add the exponents, right? So when we multiply, we add, and logs are exponents. So we're adding an exponent here and an exponent here. We're adding exponents. Same thing. What happens when we divide? X to the 4th power over x squared. What do? We subtract x to the 4 minus 2, right? So when we divide, right, we subtract exponents. What are we doing here? We're subtracting exponents. Okay, so that's another way to kind of think about it and maybe remember. And that's it. That's our beginning of logarithms. Again, practice, practice, practice. The more you practice, the better you're going to get. And the more this becomes kind of normal. Okay, even though you have a log in the middle of your problem, that's probably weird. Okay. All right. See you, people. Bye bye.